Welcome everyone, I'm Shogoto and today we'll be just going through the trigonometry introduction and the basic concepts. Okay, so let's see. So on hearing the term trigonometry, the thing that comes in our mind is the triangle and geometry. Okay, yeah, it is correct, but in a very basic and the uppermost level. Okay, so the questions that are right now popping up in our head is that why we need trigonometry, how to identify problems, who needs trigonometry, and where do we apply the trigonometrical concepts. Okay, so after this session, you will just get all the answers by yourself of all these questions. But before that, the last question, I would just like to show you some examples of the applications of trigonometry. Let's start. See, here we can see that here's someone looking like me, yeah, and standing in front of an Eiffel Tower. You all know it well. And let's just assume that you just came to me and asked for the height of the Eiffel Tower without googling it, yeah. But I could answer it to you just by applying some trigonometric concepts of the application of height and distances, and which you will just learn in the future. Okay, yeah. So if you just know all these concepts and all without any measurement or without any measuring tape, you could just tell the height of the Eiffel Tower with some minimum information. Okay, so like this we have some also different type of applications. Like in this example, what we are seeing, a building. There's a sun rising in the sky, bright and hot. On a sunny day, we have the, what it is, yeah, it's a solar panel set to just convert some energy, and we could see the sun rays falling on the buildings and also the solar panels. So we have a question that for how long will the solar panel get sunlight? Yeah, it's a nice question, because in this type of questions we need to just calculate that how much, for how long time will it get the shadow and all. Yeah, it's some more advanced type of questions, but see, in this sections also you need the basics of trigonometry. So now if your basics are not clear, then it will be a problematic in the future. Okay, so just learn it well. It will just be more easier in the later advanced subjects for you all. Okay, so let's move on. Yeah, so before everything, let's just recap some of your Pythagoras theorem concepts of the triangle basics, okay, of your previous classes, because you have learned it. Yeah, after that we will jump on from the Pythagoras theorem to the trigonometry. See, if we have a triangle, let's considering it a triangle, a right angle triangle, because Pythagoras theorem only applies to the right angle triangles. Okay, suppose a triangle ABC with the perpendicular, the base, and the hypotenuse over here, and it's the Pythagoras theorem that is hypotenuse equal to base plus perpendicular. Wait a minute, am I right? No. Hypotenuse equal to the perpendicular square, hypotenuse square equal to perpendicular square plus base square. Repeat after me, hypotenuse square equal to perpendicular square plus the base square. Okay, just keep it in your mind. So here it is given that the perpendicular of this triangle is 3, the base is 4, and the hypotenuse they wanted to know. So on applying the formula of AC square in this case equal to AB square plus BC square, which is the Pythagoras theorem, we just getting that on just making the root of both the sides, AC is equal to root over of 3 square plus 4 square, which is finally evaluating to 3 square 9 plus 4 square 16. So 9 plus 16 is 25. Yeah, so root over of 25 is 5. Okay, well done. So this is how we just found the hypotenuse of this triangle ABC, and which is 5. Okay, fine. Now let's jump on to the trigonometric section. Up till this we are just dealing with the sides, and now in the trigonometry we will just dealing with the angles also with the sides. Okay, so let's start. Yeah, so suppose we have the same type of triangle, a right angle triangle ABC, and here we also have the perpendicular, base, and the hypotenuse, and we have a new thing, a new symbol that I am just including over here is the theta. Okay, so what is theta? Theta is a Greek symbol, the 8th letter of the Greek alphabet series. Okay, we just use it for the trigonometric angles. Fine. Okay, so let's make it the angle ACB as the theta. Okay, so now let's just also think a recap of the perpendicular, the hypotenuse, and the base. So what are they? So hypotenuse is just a very simple, just the opposite side of the angle of the 90 degree or the right angle. So this is the hypotenuse, in this case AC, and then we have the base. So what is the base? Base is the side on which the trigonometric angle theta and the right angle falls. Okay, so next we have the perpendicular. So perpendicular is the side which is just the opposite of the trigonometric angle, which is theta over here. So see, in this case AB is the perpendicular of the triangle ABC, because this one is theta. Fine. Okay, so let's just consider the trigonometric ratios this time. So see, sine theta, the first trigonometric ratio, it is written sine theta. Therefore we are considering this angle the theta and the sine ratio stands for perpendicular by hypotenuse. So it is this one, perpendicular by hypotenuse for the case of theta. So it is AB by AC, right? Next we have cos theta, which again stands for in the similar way of the theta corresponding to this angle, which is the base by hypotenuse, that is BC by AC. Next we have this as a in a same is this all have a similar concept of this ratio, that is tan theta has a ratio of perpendicular by base, that is this AB by BC. And this is all just written over here. You could just have a look on it. And then we have a next type of ratio you could see over here, that is cosec theta. And one little observation is that cosec theta equal to 1 by sine theta. Therefore, it is the reciprocal of sine theta. See, this is the reciprocal of sine theta. That means if sine theta is p by h, therefore cosec theta must be h by p, because 1 by p by h is 1 by h by p. So cosec theta equal to hypotenuse, which is AC by perpendicular, that is AB. Okay, so in a similar way, we have sec theta equal to 1 by cos theta. Therefore, if cos theta is b by h, so sec theta must be h by b. And in a similar way, we also have the cot theta. It is 1 by tan theta, and tan theta is perpendicular by base. Therefore, the cot theta must be base by perpendicular. Yeah. So this all are just written in accordance of the triangle ABC. So this is your task to just find out the following. It's a very simple one. Yeah, so these are known as the reciprocal trigonometric ratios. As you could just see that these are just the reciprocal of these ratios. Okay, so after grasping all this knowledge, we shall just apply it to this type of problems, and we will be just discussing it in the later classes. Okay, so today up till now, so thank you for this class, and we just discussed all about the trigonometric ratios, and I just like to do some fun with the mathematics skills, so I just termed this as fun with trigonometry. Okay, so this was all about trigonometry introduction and basic concepts. Hope you like it. Just have a look on all the concepts and all. Have a good day. Thank you.